Hey everyone, I just thought I'd do a quick video for this homework sheet. Not really doing every single question, but just giving some pointers along the way. And there was a one tricky question, so I might explain that one as well. All right, so just taking note that the very first question is an exam 1 question, so we have to do it without the calculator. Obviously it's easy to do with the calculator, but I'm doing it without a calculator. Now you'll notice when I'm doing these questions, I do take a few shortcuts. So just bringing out 1 over 12 as a factor, and then I've also taken out this half, and that's where the 1 over 24 has come from. Now you don't need to do that. You can still leave that 2 in. You can still leave a half in, and you can still leave the 1/12 in. You will still get the same answer, but because we're dealing with fractions, it's probably a bit easier to take, I don't want to call them shortcuts because that sounds like, they are basically shortcuts, but an understanding of taking out those factors will mean it's a lot easier to do your definite integral. But you can definitely leave them in there. All right, moving on to B. So this one here, again, just a bit of fraction work. You can see I've taken that 1 over 24 out again, and then when I've brought that over to the other side, you multiply by the reciprocal. So that 5 over 8, which is here, is multiplied by 24 over 1. So to get rid of this 1 over 24 on this side, you just multiply it by its reciprocal. And then instead of doing 5 times 24, I can see I can simplify that 24 over 8 as 3 over 1. So it's just 5 times 3. So just a bit of fraction work there. All right, moving on to another exam 1 question. So for this question, knowing, I guess, your antiderivative of trig functions, but also your exact values, you can see I've taken that negative, first of all, taken that k out the front and then moved it over to this side, and then also taken the negative 1 over pi out before doing my substitution. And then again, also just knowing your exact values. So we've got negative 1 minus 1 is negative 2 over negative pi on k, and then just solving for k. It is a show that question, so you do need to basically ignore the answer that's been given to you. You never substitute it in. You basically just given it, and you have to show how to get that answer. And the reason you've got that is because you use it in the following question. So I've taken pi over 2 out the front, and then just continued on my merry way with my definite integral, and we get root 2 minus 2 on 2. Do not cancel those 2's out. 2 is not a common factor on that numerator. We've got multiple terms there, so it just stays as root 2 minus 2 on 2. All right, I'm just going to interrupt this video because I picked up this error when I was looking through the solutions. I didn't follow through with this negative, so your answer should be negative root 2 plus 2 on 2. So just make sure you fix that. You'll notice that in my original solutions, I didn't have that negative following through, hence my final answer would have been wrong. Oops, gone a bit too far. All right, still another exam 1 question. So again, setting up a definite integral, you can take that a out. You can't take this 5 out though, because it's not a common factor for both those terms, so it's got to stay in there. And just a bit of fraction work. I feel like we've done some of these questions maybe in class, but anyway. With these questions, it's just, if you get the answer wrong, it's probably just going to be your fraction work. So do take your time. This question is worth 3 marks. You've got the skills. All right, you definitely have the skills to do it. It's just, you know, as much work practice as you can get with fractions is extremely important. So if you ever do an exam 1 question, do not pick up that calculator and do it on the calculator. You need to practice your fraction skills. All right, I don't know why. Maybe question B was leading on to another question, just setting up a definite integral. Anyway, I probably didn't finish. Does it have up the top? No, it doesn't. Sometimes the question says how many marks. I do think that probably was leading into another question. But yeah, we didn't have to do anything with that. All right, now looking at exam 2 type of questions. So this sort of question won't be on your exam for this year because it's no longer on the course, but the median is just your middle number. So I can see here we've got 0.4, so your median will be at 0.5. So if we keep adding, then we're going to have 0.6. So 0.5 is going to be at 1. The continuous random variable has the value of A. All right, there's so many of these questions on here that you can see they're quite popular in exams. So if you see a question like this on your exam, you should be super excited because it is so easy to do on your calculator. You just do solve, and we're solving for A. Just make sure you get your inequality correct, so it has to be greater than A. And because we're solving for a trig function, you do need to restrict A. So if you ever go to solve and it's a trig function and you get a general solution, just go back in and restrict whatever it is you're solving for. So we are solving for A, so we need to just restrict A for this one. All right, and question 11 was very similar. This time we've got X is less than A, so you can see I've got that up the top there. I did not let that equal anything. I probably should have done that. Is equal to 0.25, and we're just restricting A. All right, so restricting A because it's another trig function question. All right, question 12 is a binomial question, and it doesn't say that it is. So when you're doing binomial, you would have noticed some questions it actually says binomial. But this one, you've got a context, so you've got to think about what gives it away that it's a binomial. All right, so we've got a soccer player practicing her goal kicking. She has a probability of 3/5 of scoring a goal with each attempt. So each attempt, it's independent. It doesn't say that it's independent, but it basically implies with each attempt it's going to be the same thing. Hence, it's independent. Binomial you can only do if it's independent. She has 15 attempts. All right, so we're looking at discrete, basically. So 15 is our value of n, so 15 trials. And we want to score less than 7. So when you're dealing with binomial or discrete, it is extremely important that you get your inequalities correct. Now, I always think it's a good idea to actually state, and so you think about it a little bit more deeply before just plugging it into your calculator, what your lower limit and what your upper limit is. So here we want less than 7, so your lower limit is going to be 0. And we want our upper limit to be 6 because it has to be less than 7. And because we're dealing with discrete values, you can't kick half a goal. It's either a goal or it's not. So your upper limit is 6, and then the rest, what you plug into your calculator. So just a straightforward calculator question. But if you put a 7 as your upper limit, you would have noticed that was one of the options. So yeah, a question where it should be pretty straightforward will get you because of that inequality. So just be careful with your inequalities. All right, moving on to question 18. Similar to before, it's all good. Let's move on. All right, this one I felt was a little bit tricky. So I want to explain how I attempted this question. In the assessor's report, I feel like they did it slightly differently to this, or maybe they did, I can't remember. But I thought I'll attempt it again. It's the first time I attempted it, I didn't get an answer. All right, so consider the discrete probability distribution with random variable x as shown below. The smallest and largest possible values of your mean are respectively. So your mean has to be somewhere between your lower limit and your upper limit, somewhere between -1 and 4. And we can see that we can't eliminate any option there because they all fall between -1 and 4. If you wanted to, you could probably think about eliminating maybe 0.8, only because, I don't know, it feels a little bit too close to -1, but let's have a look at how we approach this question. All right, so the sum of all your probabilities has to add to 1. So that's what I've done here. All right, just added them all up. So we've got this A, and then we've got 4 Bs, and then we've got 0.2. So I've just rewritten that to get B in terms of A. So B is equal to 0.2 minus A. So basically B can be anything between, it can be 0, but the maximum it can be is 0.2. All right, so it's got to be between 0 and 0.2. So basically, if A was 0, B would be 0.2, and if B was 0, A would be 0.8. So we're going to have a look at that in a sec. All right, so let's have a look at the first situation. So if B was at its maximum, which is 0.2, A would be 0. So I've just gone ahead and calculated the expected value for that, which is 1. And I've done the working out here so you can see it, but I would probably just do it straight onto the calculator just to save a little bit of time. This was quite a time-consuming question. So that's my max. So you can see I've crossed out B and C when I was doing this. It didn't really help me, even though I knew you had to have the highest mean was 1. So then I said, all right, well, if B is 0, that means A is equal to 8. So then I went ahead and substituted that into the expected value formula, and I get 0. So your minimum is 0, your maximum is 1. All right, so a bit of a tricky question. And I can't really think about how to do any elimination for that other than maybe cancelling A and B because they're very close to 1. But even still, yeah, that probably wouldn't be your minimum. But anyway, let's move on. All right. Scroll down. All right, the time Jennifer spends on her homework each day varies, but she does some homework every day. All right, so we've got continuous random variables. So we've got this function, we've got 2 of them. Just make sure when you graph it, you're sketching at each part of it. So you've got 3 components here. You can see it's also worth 3 marks, which is pretty generous because I kind of feel like, other than the scale being a little bit annoying, so you did have to make sure you're at 45. That's something that may have stumped a few people. You do have to do this 0 elsewhere. So you got to make sure you clearly have lines here on your t-axis. And this is symmetrical. So you could put this straight into your calculator and see what it looks like. But that scale, because of the way it's designed, I feel like it's a little bit trickier than just if it had the numbers on it, obviously. All right, I just need to interrupt this question as well because I did it incorrectly. You would have noticed in my original solutions that are in the video that I had 0.5 for this first part, but that would only be true if it went from 20 and we're going from 25. So my original answer was incorrect. So I'm going to delete that from the video anyway, but you can just put all this into your calculator and you should get 0.8. And I can see with that space there, it's definitely an exam too. Now, question C, we've got a conditional probability question. I was trying to think of the word. So just making sure you know the conditional probability formula, and then you can just do that on the calculator. It is worth 2 marks, so you just can't give the final answer, unfortunately. So doing something like this to demonstrate you understand that intersection between the two is extremely important. So probably setting up those probabilities, and you could even put that in. The 0.82 has come from the previous question. Oh, we don't want it to go from 0 to 55. Oops. Oh, no, I just did it. Oops. I just realized I made a boo-boo. All right, because the previous question was from 25 to 45. All right, I need to fix that up. I've decided I'd do it with you. Whoops. Oh gosh, this is annoying now. All right, so what we should have had on the bottom is 20 to 55 because that would have been incorrect because we're not going as far as 0. Let me just double check that. Yeah, so our lower going from 20. All right, so from 20 to 55 and 20 to 25. Now, I did want to just keep recording so I can show you on the calculator. So you could set up a fraction like this, and the first one, we're just going to do continuous and normal CDF. Not normal, oh my gosh, I've been doing too many normal questions. Continuous. Oh, what am I doing? Silly me. Oh my gosh. Sorry, guys. There we go. Oh, I'll get there eventually. There we go. All right, we're going from 20 to 25. And just make sure you do the correct function. So we're going from 1 to 6 to 5. And I'm just going to, I'll use t. T minus 20. And that's dt. And then the other one, now you could do two separate definite integrals, or you could do 1 minus what you don't want. So I'm just going to write that here. So this part here can be 1 minus what we don't want, which is the probability that x is greater than 55. So on my calculator, let me just get it back up. I'm just going to do that 1 minus. So instead of doing two definite integrals, I'm just going to do 1 minus what we don't want, and that's what we're left with. What we're left with is exactly what we want. All right. So we're going from greater than 55, so 55, and our upper limit, memory was 70. Let me just double check. And it was 1 over 625, and then 70 minus t dt. All right, so we got 0, 0 point, oh, doesn't want a decimal answer, so we've just got to go back up. Just make sure you give it as a standard, so 1 over 41. Did I have it before? I feel like I did have that as the answer. Did I, or was that a previous question? I have no idea now. Anyway. Find A such that the probability of t is greater than or equal to A is 0.7. So here I've drawn the diagram before again. All right, so instead of scribbling on the one above, I'm just going to draw it here. So t has to be greater than A, and we want that to be 0.27. So because it's symmetrical, here's half this line. Let me just highlight it. So this line here splits it in half. So either side is 0.5. So obviously A is going to be down here. All right, so what I can do is I could set up two definite integrals, or I can say, well, instead of letting it equal 0.7, let's let it equal what we've got on that other side, which is 0.3. So now my lower limit is 20, my upper limit is A, as opposed to doing it the other way around. And A is equal to 39.3649, because we had to do it to 4 decimal places. All right, question E is an example of where we use binomial within continuous random variables. So we've been basically dealing with continuous random variables up until this point. And now what gives me the indication that it is now binomial is that it tells us this probability. All right, it's a set probability. Sometimes you have to work it out, but it's told us that it's 8 over 25. Assume that the amount of time spent on a homework on any day is independent. All right, so that's also giving it away that it's binomial. All right, more than 3 of 7 randomly chosen days. All right, so we want 3 days out of 7 days. So it is discrete probability. So we're setting up our binomial. Just remember it is more than 3. So that means we've got to use the greater than symbol. So on our calculator, we've got to do our lower limit is 4. All right, can't be 3 because we're dealing with discrete now, not continuous. So 4 and our upper limit is 7. All right, so just on your calculator, distribution, discrete, binomial, CDF. So your lower limit has to be 4 and your upper limit is 7 because it's 7 days. And then your probability of success is 8/25. All right, and it says to 4 decimal places. All right, my battery is dying. Oh my God, am I going to finish? All right, find the probability that Jennifer spends more than 50 minutes on her homework. All right, so this is where we've got on at least 2, so that means we're going to include a 2, given that it's at least 1. So just setting up your conditional probability. So 2 marks, you just do that straight onto your calculator. Just make sure if you are using this fraction button, when you do your binomial, why do I always go to that one? Binomial CDF. All right, so our lower limit is 2, our upper limit is 7, the number of trials is 7, the probability of success, I think it was 8/25. All right, it'll say error, so it's only because you've got that fraction, and then you just put the other one down the bottom. So we could just, highlight that and bring it down and change that to 1. All right, easy peasy. All right, I'm just conscious of my laptop battery dying. All right, question 5, similar to what we've done before. Oh, actually, no, it's not similar. So this time we're solving for A, which is a part of our definite integral. So before we were solving if it was a part of our probability. So because it hasn't told us anything, often if you're solving for A, you just let it equal 1 because the whole area under that curve is going to be 1 because all your probabilities have to add to 1. Right, that's a common question. And this one here, because we've got 2 functions, we've got this one and this one, and we want it to be 0.35. What I would do first of all is just have a look at the area for this first part function, and I get 0.625. So that means x is less than k is equal to 0.35 has to be within that first function. So that second one is even important. But if it was equal to, say, 0.8, I would then have to use this second function because obviously the area would be under that. All right, there we go. Computer hasn't died yet. Bye, girls.